Hi, today we're going to be talking a little bit about volume and how it's related to density. So first we need to know that density is mass divided by volume. So mass meaning how many grams, right? Remember we learned that in our last unit that we measure mass in grams. So here I just have a normal tennis ball. And let's say I were to take the mass of it, I'm going to come up with some made up numbers that work real evenly and easy so that I can make the point. Let's say that this tennis ball is 50 grams. Okay, its mass is 50. And then its volume, remember we can get volume of a solid by submerging it in water in a graduated cylinder to figure out the volume of it. Or there are mathematical calculations you can do as well. Let's just say that it's 25 cubic centimeters because that's an easy number to use with 50. So mass being 50 divided by volume being 25, you would end up with basically 2, right? 2 grams per cubic centimeter. But let's say that I took all the air out of this ball, shrunk it down as much as I possibly could, and got it as flat and small as possible. Would the mass of the ball change? Actually, would just slightly, because there probably is a tiny bit of mass in the air that's in the ball, but not even measurable because it's such a small amount of air. So we're just going to say that the mass still stays at 50, even though it might be 49.8 or something like that. But would the volume of the ball change? The amount of space that it takes up, is that going to change? Well, absolutely, that's going to change, right? We're going to squish it down. It's going to become much smaller. And let's say that it goes from 25 cubic centimeters to say 10 cubic centimeters, right? So it's a lot smaller. The volume changed, but the mass really didn't. And so now if you look at the density, it's mass divided by volume, the mass still being 50, the volume being 10. Now the density is 5 grams per cubic centimeter, right? So as volume goes down, as the item takes up less space, but the mass is staying the same, it's getting more and more dense. In other words, the particles are squished tighter together. So if you look at the tennis ball, obviously when it's open like this, the molecules are more spread out, making it less dense. But when we squish it all together, we're squishing all those molecules together and they're tighter. And that means that they are more dense. Trying to find things around the house. We've got a paper ball now, right? And so right now I have a paper ball. And if I squish it as small as I can, the volume's getting a lot smaller, but the mass is pretty much staying the same. So what I'm doing is squishing all those molecules really tight. And density has to do with how tightly things are packed. So when do you think it was more dense? When it was big, like a big ball of paper, or now?